So jumping right in, this is what our portfolio looks like. Most of it you see here. So the indoor AP12 LTE, we have not gotten our AP11. We've introduced AP13, which is kind of a ruggedized indoor form factor. But more excitingly, we actually now have a 5G portfolio. And there are 3 SKUs that we have made available in the US and Europe, and I'll talk about the additional SKUs. So this is a 5G outdoor access point, right? This one here is a multi-mode LTE and 5G access point, and I'll talk about why that is needed. And this one here is a 5G only indoor access point. And all of those 3 are available in support different bands. So you have N48 SKU, you have a SKU for N78 in Europe, N77 in UK. So we now have a full portfolio of access points that we can now make available to customers in the US as well as globally. Celona Edge right here is running the converged core, is running 4G, 5G services. The data plane is unified. So all of those features that I talked about from an external IP domain perspective, supernetting, microslicing, all of those are actually available across both of your networks. So it's in some way radio agnostic. So all the cool features in the product are available irrespective of the radio technology. And then the orchestrator, which I just showed from an operational workflow, from a customer perspective who's used to deploying a Celona 4G network, deploying a 5G network is going to be no different. The operational workflows are also going to be extremely converged in that sense. A quick education piece here. So for those of you not aware, all spectrum, private spectrum in the world are not equal, not created equal. N48 CBRS is being used in the US. N77, N78 is what's being used in UK and Europe. We do have SKUs available for those today. N79 is being planned for second half of this year. That's going to be targeting the Japan market. And the way of procuring these spectrum is different for each country. So in the US, it's SaaS and automated. In a lot of the other countries, it's basically paperwork exercise where you actually request for spectrum and basically get a dedicated spectrum for that location if it's available. The good thing, however, although there are multiple bands and all that, they're all kind of converging to 3.3 to the 4.9 gigahertz range. All right, before I hand it off to Prince, this is our vision, and especially in the US, because outside of the US, all the private wireless spectrum that's becoming available is becoming available for 5G. So the products that we have launched for 5G are we only launched 5G products for the international market. For US, however, because there's an incumbent 4G deployments and there are 4G devices which are very mature, we believe that over the next few years, you're going to have a combination of 4G and 5G devices in your network. And you need a vendor and a solution that allows for that converged concurrent operation. So with our converged 4G, 5G core, with our multi-mode AP that can either operate as LTE or 5G, and our kind of converged operations, we now have the ability to give customers an ability to start with 4G today and then migrate to 5G whenever they are ready. So we have designed our product for that. We have designed our pricing for that allows them for that upgrade capability, and I'm happy to talk about that in the breakout session. But overall, this is what Prince is going to try and demonstrate in the small network here. But the idea is that customers in the US today are solving problems using 4G, and they will continue to do so for the next 12, 18 months as they start introducing 5G devices into their network. The question is, how does your solution evolve with that journey as the customer makes that?
So the AP20 is that one radio that can be either 4G or 5G?
There are 2 radios.
And they're simultaneous 4G, 5G?
So today, it's basically you can operate as 4G or 5G. And the idea is that customers who are thinking of future-proofing, they'll deploy it as a 4G network.
And then they're going to have to switch once they have the client, the 5G client.
That's the idea.
Got it.
Okay, so now let's actually go through some of the actual devices and the private network. So what we have for you here is an LTE network up and running. 5G network that's up and running. I have few 4G devices that are connected to the AP12, which is the LTE access point. I do have 4 to 5 5G devices that are connected to the AP21. AP21 is the ruggedized access point. We actually call it like the indoor/outdoor access point. because it can be power reduced all the way up to 0. So it can be totally power reduced to indoor operational levels, though it's a ruggedized access point. We do have the converged core that's basically running here. It is a single node edge cluster right now, and it has got the LTE services, the EPC services, as well as the 5G core services running on that. Celona orchestrator, we actually spawned a Celona orchestrator session for the event. So we do have organized session, MFT event. MFT is the MFT 2023 is the customer, and we'll showcase right now. Okay. So let me go into the orchestrator. This is the organized session that we built mainly specifically for this event, the MFT 2023. So we have one edge cluster, that is this one that's running right here. The edge node is the same, 2 access points, one LTE access point, one 5G access point that's running right here. Do have 5 active devices, 2 of them are inactive. It's basically no data activity. This is something that we actually, this is pretty interesting. I know Puneet talked a lot about the experience history. So we were actually trying to set it up. We came and set it up yesterday. We turned it off. We were trying it multiple times. So that's why you can see this period. So it's truly reflecting what is happening in the cloud. The setup, the APs coming up, devices connected, and tear down. And we tried it like three times yesterday. Just want to make sure that everything is up and running pretty well. Sites ranked by experience. We do have 2 sites, a 4G site, and we do have a 5G site as well. So a 4G site is the LTE access point, and the 5G site is the 5G access point. You can also set up one converged site with 4G and 5G operational at the same time as well. Okay, let's go into the sites. And as you can see, the sites, the address is right here. So we've got the spectrum. The SAS has granted, Federated has granted the spectrum for the specific address. And how we've actually got it, and we can go through the details of it, is we've got the 5G at the high end of the CBRS spectrum and the 4G at the low end of the CBRS spectrum. Okay. So let me quickly walk through the site creation workflow. As you guys know, for US-based sites, an example would be US-based sites, you have to go through SAS. And basically what we have actually, as Puneet was talking about all the internationalization and the international product launches, what we basically have enhanced the orchestrator support to support for multiple geographical locations worldwide. So for US, it still has to go through SAS. The available band that available in US is N48. And then you click on the radio technology, if it is AP20, can actually operate in LTE or 5G, as Puneet was pointing out. So the moment you click on LTE, the AP12, the AP11 pops up on the moment, or the AP20, depending on the license you buy. The moment you click on the 5G, AP22 or AP21 pops up right here. Okay, let's quickly go through another example where want to check the site readiness for international markets. So an example, London. Boom. There's no SAS that's available for the international markets. As Puneet was mentioning, you actually have to get that spectrum from the local authorities, authorities for that specific enterprise. So for UK, what we have seen is the bands that are available are 77 and 78. And again, if you do the same thing for Germany, we pop up based on the regional locations, the bands that are private spectrums that are available in that location. So here, a couple of things I want to go through. The enterprise might have got a subset of that spectrum. So you can actually put the start and the end, and then configure your site accordingly. In certain cases, what we have also seen is countries like Netherlands, they have 50 megahertz in the high end of the spectrum and 50 megahertz in the low end of the spectrum. So you can actually have the same site with multiple ranges.
Is it as simple as typing it in there to activate the radios?
Absolutely.
So there's no
Check.
spectrum release key to say, yes, you're allowed to have this?
So it's enterprise's responsibility at that time that they have actually procured it. Like in the US, it's managed by SAS.
Right.
in UK and Germany, the enterprise takes the responsibility saying that we have procured it, and then we are saying we're going to use it. So if they have not procured it, then they are liable. Yeah.
Okay.
But yeah.
But yeah, exactly. So this configurations pop up right into the RAN configs and the end-to-end the configs as well. Okay. And the radio technology, LTE, 5G, the APs that the enterprise have bought, that pops up like right there. And only the ones that are specific to that country will actually pop up right there. So if it is in a different country and the band is not supported, it will not pop up in the list. Okay. So let's go back to sites. So the 5G AP is on the specific site that we have created. Want to quickly go through the edge cluster. So as you can see the edge cluster right now, the IP address of the edge, the specific edge cluster that we have created for this exercise is MFT 2023. So that's the one right here. And again, it is converged. So it's got the EPC services running on it, as well as the 5G core services running on it, along with other DP, SON algorithms all running on it as well. PLMN names can be changed depending on certain private enterprises want to change. We can change it like right here. You can see the number of devices, right? So the total number of devices that are connected, that includes both LTE devices and 5G devices because it's a converged core. So this is truly the actual number of devices that are connected. I believe about 8 devices are connected, right? 6 to 8 devices are connected. The LTE devices are actually going inactive. The throughput on the devices, we do not have multiple edge nodes. We only have one edge node in this location. The top talkers on the network, I actually have my laptop that's running on a dongle, on a private 5G dongle. That's this one that's been basically connected the Zoom through that. So my laptop is actually connected with a dongle, which is running private 5G. So I turned on Wi-Fi, turned off Wi-Fi, and I've been running this. Actually, this private 5G dongle is basically on a micro slice, running on a micro slice as well. Okay.
We just had a question on what power and channels are you using?
It'll go very good.
Oh, get there.
So,
Okay.
yeah. So let's go straight into the access points. So on the 5G network, the operational status is up and running. Specifically on the power question, it is 40 megahertz channel bandwidth. We've got the 3650 is a sender frequency, so it's 40 megahertz. You got from 3630 to 3670. So that's the channel that it's operating on. That's the channel that the 5G AP has got the connection. We have power reduced it to operate at indoor power levels, which is 30 dBm, and the SAS grant is there. So if you actually go back to the 4G AP has 2 sectors, 20 megahertz each, and that has got the spectrum basically on the lower end of the CBRS. So it's got the 3550 to 3570, the 20 megahertz chunk with the sender frequency of 3560 and 3590. So basically both the channel, the power is right here.
And so just to confirm that you've registered your GPS coordinates, sent them to SAS, SAS responded back.
Exactly.
The channel can use, and we authorize you to max power.
That's right. That's exactly right. So if you go back to the organization, and if you go to the sites, we have entered the exact address for 949 Great America Parkway to trigger the.
Actually, if you go to the AP access point prints,
yeah.
So within the access point, there's a CPI workflow. So when you go to the antenna parameters, you can actually specify the exact lat long. So the CPI installer, in this case, it was one of our QA engineers who's CPI. He basically certified that this is the location this AP is in, and that entire CPI workflow is actually here. So from a customer perspective, if they have a third-party CPI installer that they are bringing in, they can create a role so that that CPI installer has access just to do this and nothing else in the product. So yeah, that's CPI workflow is actually built into the product.
There's a certificate that they have to upload too, right, in there? No? Or is that
Sorry?
the CPI installer?
Yeah.
There's a certificate that they have to upload.
Yeah. So the CPI, so as part of their, when you create a user, CPI user, when they log in, they
Okay,
first
so
have
it's
to,
just one time, right?
yeah,
It's
that's
one time.
Yeah. And here they just say, yes, I'm signed up, and then you're going to use the certificate that they did as part of the user creation to sign off on it. Yeah.
And in terms of powering the access points, can they all be powered by a PoE? Or
Oh yeah, so great point. So basically, this is powered by PoE plus. The AP22 is PoE plus plus. The AP20 is PoE plus plus as well. So AP22, which is a 5G only access point, is PoE plus plus type 3, and the AP20, which is the dual mode, is PoE plus plus 802.3 type 4.
and then the outdoor one needs separate power.
Yeah, the outdoor is completely, it's DC in and AC out.
For those of us who don't have all the types memorized, can you just give wattages? Like how many
Yeah,
watts?
absolutely. Oh, yeah, that's a better. So the AP22 is 60 watts in.
Okay.
And the AP20 is about 71 watts in. So that's why it's type 4. So AP20 is actually 50 watts in and 70 watts. So if you have a PoE,
I haven't seen a device needing the 90-watt profile before, so first time for me.
yeah. So most of the cellular device, most of the 5G devices, we have seen it is consuming anywhere between 40 and 60 watts.
But I think time-wise.
Okay. Yeah. So very quickly, the active devices. So we have the Digi CP that's running, and as Puneet was talking about, like the tablets and everything. 6 months back, the ecosystem was completely nascent. We couldn't even find devices to validate the solution. But in the last 3 months, a lot of these devices have emerged. We have the tablets that are being used very commonly in the factory floors for connected IT workforce. This is the Zebra TC78 scanner, which is used for all the retail kiosks, checkouts, and everything. So they are all running on private 5G network. The TC78 is running on eSIM, versus the other ones are running on physical SIM as well. So basically what we have done right now, what we want to show is one of the laptops is on a micro slice, which is connected to the dongle, which is a 5G micro slice. What we have basically configured is a micro slice. And again, we have abstracted as much as possible. There is a 3GPP equivalent very term for 5QI3 with a specific delay budget, specific packet error rate, and specific latency. So we have abstracted that as a real-time and control. 3GPP also defines that as real-time and control. So you can actually, if you go here, you get the details of that, but we've abstracted that information as much as possible. So what we're doing is we are guaranteeing 10 meg uplink for the 5G dongle. At the same time, from the Zebra tablets, we will be pushing in 20 meg of traffic. What you will actually see is in 3 windows, the first window with a micro slice, the second and the third windows without a micro slice. The first window, the traffic holds 10 meg guarantee as defined in the micro slice, versus the second and the third, as we add devices, it kind of throttles down. So that's what we want to show you right now.
Maybe you can show the application definition quickly, or how you define the application.
So how basically we have defined the application is you can actually define the application by 5 tuples. We can define the applications by DNS 5 tuples. In this specific case, what we've actually defined is by port-based definition. We have actually put the 8801 port as the micro slice port. So basically, any traffic that's coming on that is mapped to a device group. We have put one of the Conda dongle onto the device group, and we have put these port numbers. We have any traffic that's coming on that port is on a micro slice, and we have defined the micro slice to have a guaranteed bitrate of 10 meg uplink.
What about something like, I guess if I'm running Microsoft Teams, Zoom, something like that?
You can do it on a full device basis, or you can do it on an application with the 5 tuple base.
It's going to be a combination, right? So it's going to be a device group and then what application it is. So yes, you could do it on Teams, you could do it on Zoom, as long as you have a definition that you can use. For example, in case of Zoom and Team, you probably will use DNS-based application identification, and you could actually classify that.
Okay.
Yeah. So you can see in the micro slice here, right? So you have a device group. So you can actually put the devices into that device group. And then on top of that, you can actually define the applications. And then the actual definition of the guaranteed bitrate, how much you want to give to that.
And this is just an example of what application we don't want to keep it simple on what you want to do here. But from a customer perspective, they could have any application. It could be Teams, It could be a robotics control signaling message, whatever. However they want to define it, the application identification classification engine kind of gives them the flexibility to define it however they want.
Okay.
Okay. So let's do what I want to run right now is
While he's making it run, can I ask a question?
Yes, please.
So, a lot of promise of 5G around latency,
Yeah.
particularly in the industrial
Yeah.
space. You haven't got any IoT devices there, right? Are we starting to see 5G IoT devices with wider subcarrier spacing that will give us the lower latency? And do you have any on your network?
So so a lot of the ultra low latency. So for us, the latency guarantee that we can provide is 10 milliseconds, under 10 milliseconds. That's where we are right now.
Okay.
Now, obviously, with 3GPP release 16 and 17, you can get in the 7 and 5 millisecond range.
Right.
So I think we are at the 10 millisecond range from a network perspective at this point of time.
Okay.
Right? And of course, there are certain applications that probably do require that. But most of the applications that we are seeing, like for example, the PLC applications or the Profinet, they're in the 50 milliseconds to 100 milliseconds. As long as you can guarantee it that it doesn't exceed that, I think those are the kind of applications we are seeing today.
Great.
Yeah.
Thank you.
Yeah. And maybe just to add, I mean,
Mehmet,
the value, the 10 millisecond latency Puneet is referring to include the device as well.
Yeah.
Of course,
Yeah.
this, to answer the question, we have not seen devices yet which can go lower. So it's kind of both parties, right? Both network and devices need to work together, and those SCS values, right? Subcarrier spacing and so forth are in 3GPP standards, but the actual products out there, frankly, are within that 5-10 millisecond latency range right now. That's the reality.
Thank you very much.
let's show that.
Yeah. Explain this quickly.
So very quickly on the microslicing, before we actually go through the demo, I have my laptop that's connected to the 5G dongle, and I have the two Zebra tablets. The laptop that's connected to the dongle, that's on a microslice. We are listening on the port, on anything on port 8801 to 8810. By definition of the microslice, it's microslice. We are putting a guaranteed bitrate of 10 meg uplink and downlink on this, versus the Zebra tablets are not on a microslice. And on the application server, we are actually listening to all the three devices, or we are seeing the traffic that's coming in different ports. So that's the setup that we wanted to show right today. So this is on the application server side. I'm listening to the three different devices. The first device is a microslice device, which is the laptop, the dongle. The second one is a Zebra tablet, and the third one is a Zebra tablet as well. So let's generate traffic. Again, this is going through laptop on the dongle. Okay. So I'm actually generating 10 meg traffic on the microslice device. You can see that you're receiving 10 meg on the server side, on the applications side, server side. Now, from the Zebra tablet, which is not on the microslice, will be generating about 20 meg traffic. And keep in mind that this device is actually on a downlink slot pattern, which is the downlink heavy pattern. And there is the maximum uplink at this point of time we can go up to is 30. So we are doing 20 meg on the Zebra right now. So you can actually see it's already throttled down a little bit, versus the microslice device stays 10 meg. Since we are giving 10 meg guaranteed bitrate to the dongle, which is representative of a critical device in a factory floor, that stays the same. So now let's add one more device and see how the traffic works. So this is another Zebra device, and I'm opening it on port 556. So you can see the traffic is shared between these two devices, which are not on a microslice, but the ones that is guaranteed 10 meg stays the same. So we wanted to kind of showcase the 5G microslicing as well. So all the technologies from LTE world, we've actually brought it to the microslicing, and we've truly made the scheduler to core to the orchestrator end-to-end solution work with us. Okay. Cool. Thank you so much, guys. Thank you. Back to you, Puneet.
Thanks, Prince. And I guess the demo gods were smiling on us today. That's good. So just wanted to quickly give you a sense of what's the path forward for us. And as we've been on this journey since 2019, I think it's only fair that we share what's going to come. So obviously, as we get into these enterprise networks, we're not trying to reinvent the wheel. We don't expect this to be an isolated island network. This has to integrate with the existing enterprise infrastructure and systems. So we are in a constant kind of path to see how we can integrate with Wi-Fi, firewalls. People ask us about SD-WAN. Is there a kind of better together story there? IoT security solutions, because there are all of these IoT security solutions which are doing behavior analysis on devices. But for that, they need to know the IP address of the device. And the fact that we make that visible kind of makes it a very nice, better together story. So we're working on that. And as I said earlier, from a where does the edge operating system get deployed? We're talking to hyperscalers and edge compute. As the enterprise story evolves, we want to make sure that we are there to support them in that journey as well. I know there was some excitement around neutral host. So obviously, we've been working with operators, and especially one operator where we actually have a trial going on with a neutral host solution at a real retail store. And I'm sure Mehmet will hopefully be able to talk about that publicly in a not so distant future. And then we'll obviously be adding other operators that we are talking to. And the goal, for those who are not aware, the idea there is that in addition to the private network for these industrial use cases, if you can use the same network to actually solve in-building coverage problem and use that as an on-ramp to connect back to a public operator so that Puneet, I, as a subscriber, as a T-Mo, Verizon, AT&T subscriber, walk into a building, connect to the private network, and then that connects back to the macro network. And from my perspective, I continue to use the same services as I would if I were directly connect to the macro network. That's what that particular solution entails. And that's very, very powerful and kind of opens up additional markets for us. So we're obviously keenly working on that, but obviously there's a dependency on the service provider side there. As I said earlier, with additional bands, we are going to open up additional geographies. So today we are focused on US, UK, Europe, Canada, Mexico, other countries that we are seeing interest in. And a lot of these other countries that are going to come by are, what we are keeping an eye on is where is manufacturing moving, right? A lot of these manufacturing is now moving to India, to Vietnam, to Philippines. And a lot of these places actually have N78 spectrum available. So as we look at those countries, how do we make sure that our products are available to serve that specific use case? And then, of course, we just launched our 5G products, and then people are already asking for, hey, what is your next generation 5G platform going to look like? So Prince and team are already kind of evaluating what our bigger, better, faster next-gen AP platforms will look like while these start to go into market. And there, things that Avril was talking about from an ultra-low latency perspective, high-capacity, precision location services, those are the things that will start to become a reality.